gentlemen, next on stage, we will hear about a very unique and innovative self-learning technology, reverse engineering the human perception for autonomous driving. Please welcome on stage the Vice President Strategist at Autobrains, Manuel, Yoon.
Imagine a world in which you don't have to drive anymore. Autonomous cars will take you from A to B. They are sustainable, they are affordable, and they are, of course, safe. In this world, there are no more accidents. Let's be honest. How many times have you heard this promise? This promise of autonomous cars becoming a reality. The promise of safe, autonomous, and sustainable mobility. But I think none of you came here in an autonomous car, right? Maybe some of you came driving. Some of you took a bike or took a scooter, or maybe some of you even came on a horse or a horse carriage. I work for Autobrains. We are an AI software company, and we want to make autonomous driving possible. And I can tell you, we look at a lot of video data, and there are some strange things on the road that you wouldn't even believe. I want to show you one example of such a horse carriage. It's not our video, but it went viral last week. And you as humans, you see the horse carriage. Yeah, the horse carriage there is driving on the street. I think you are laughing already. You can immediately see the horse carriage. But the interesting question is, what does an AI see? And I want you to pay attention to the screen of this autonomous or assisted vehicle and look at what the car is seeing. So at what object is this car actually identifying this horse carriage? Can be a truck. Suddenly it's a oncoming truck driving towards you. It's a pedestrian behind the truck. I saw a pickup. And you can already see the AI has a lot of problems actually identifying what this is. And you didn't hear the sound in this video, but I would be scared as hell. But the people that are actually recording this video are having the time of their life. They are laughing at what this AI is actually seeing and what this AI is doing. And of course, all of these things are not a horse carriage, but I think immediately there are some interesting questions to ask, right? So why are there different classifications? What is happening in this image that you go within 30 seconds to 8 different type of objects that this AI is classifying? In especially this scenario where I was personally scared is when it is identified as an oncoming truck towards you. I would have been scared because actually the vehicle is not braking autonomously, right? It continues to drive towards an oncoming truck. And I'm giving you this example of Tesla here because not to bash Tesla, because I think their technology and what they've achieved in e-mobility is actually amazing. But you have to imagine there are more than 1 or 2 million Teslas on the road that have a lot of data. They should be able to detect some of these edge cases that we see, but it was still not able to do that. And so with all the technological advancement that we have, autonomous technology for cars is still not ready. Right? That is the reality. And the question is a bit, why is that the case? Because I think since the last 10 years, I read this last week on Forbes, the industry has invested more than $200 billion into autonomous vehicle technology. And still we see things like this. From our perspective, it's because we need to radically reimagine how we think about some of the AI technology. And the technology that we use today and some of these technologies are really hitting a wall. I'll bring you 3 examples why that is the case. Number 1, the whole industry today is relying on manually labeled data, right? There are literally thousands of people in the world that are drawing bounding boxes around different objects, yeah? Around pedestrians, about trucks, and somebody forgot the horse carriage in his job. And this is really taking a limit towards you can really analyze and how you can perceive the world. So there's a lot of labor-intense manual labeling going on with which companies like Tesla and others are feeding their AI to make autonomous vehicles possible. I think it's about 80% of the time or effort that goes into only refining and managing the data before you can actually do something with it. And all of this needs to be supervised and so on. The second reason is, once, let's say, you've classified an object or a horse carriage, then you need to translate this into a driving task. So what should the vehicle do? In the case of the horse carriage, we didn't see the vehicle brake, where maybe it should have, if it at least recognized it as an oncoming truck. And this is quite complex. For example, the AI detects a human, a pedestrian. The pedestrian is walking across the street with 5 kilometers per hour. My car is driving 40 kilometers per hour. In how many seconds will I have a collision with this pedestrian? At what meters do I want to brake before this collision happens? So all of these are formulated into functions for the car to operate and actually brake, accelerate, or steer. And you can imagine this can become quite complex. So some of the players in the industry follow another approach, which is to say, let's forget all about these perception and functional tasks. Let's just take the sensor input of good drivers and their decision making into one gigantic end-to-end network. So the end-to-end network learns based on the camera and the radar input and everything that was seen, and based on the good driver behavior, what should be done in the next situation. But you can imagine with such a complex world, such networks become gigantic. They become very large, and you need to do a lot of deep learning with these networks. And they become also a black box. So it's very hard to understand and also to predict what comes out of such a gigantic network. So you see all of these approaches are kind of hitting a wall and are not getting us as fast as possible to autonomous cars as we would like to. So what we do at Autobrains is we actually mimic how humans learn. And the founders of our company were actually in the lab and they looked at mice, and mice were shown different images, and they were analyzing how the neurons are firing through the brain and what's actually happening when humans and mice perceive something. And I want to introduce to you 4 technologies that we use at Autobrains to actually mimic human-level perception with AI to make autonomous driving faster and faster to the market. That's signatures, that's self-learning AI, which is a fundamental shift in how we do AI today, and perception fields and an ensemble of narrow AI agents, what we call EON. Let's jump into signatures. The first problem that you have of the world is really a representation problem. So how can you get everything that's happening in the world into the machine? And instead of labeling the whole world and looking at different objects and classes, what we do is we take image input and we create signatures. And you can think of these signatures as numbers. They are generic representations of the world. They are highly compressed. So we don't need a lot of memory and compute power to actually have a powerful representation of the world. And based on these random signatures, what our AI can do is to find interlinks, intermatches, and clusters. So you will have random signatures, and the AI recognizes patterns in these signatures. It was not yet told whether these are pedestrians or cyclists or horse carriages, but it will identify these similarities in these patterns into concepts. And you can have many different types of concepts that are not yet predefined. And when you put all of these concept signatures into a database, you have a very powerful representation of the world. So this is a fundamental shift from predefined classes like cyclists, trucks, cars, etc., to a very deep contextual understanding of the complex environment that is our world. And this you can use for then the perception tasks of a car. Once you've done that, what the whole industry is doing today is to use these labels and train their machines. This is the approach of supervised learning. So to do this in a simple explanation, what you would do is you give a machine 1,000,000 images of a banana, and you've labeled it as a banana, and the 1,000,001th time you show it a banana or an apple, you hope that the machine also recognizes it as a banana or an apple. Okay? What we do differently is we don't tell the machine what is a banana or what is an apple. We show the machine these random images, and the machine for itself figures out where are similarities in these images. And so it can identify them into different clusters. This is what we call unsupervised or self-supervised learning. Nobody has told this machine this is an apple or this is a banana, but the machine will sort that out itself. And so you can, in the end, tell the machine what it is. So with this approach, we're much more mimicking how humans or how little children actually learn. And we fundamentally believe that in this unsupervised learning approach, we have an advantage because you don't need to have labeled data of the world, but you can still train the machine to identify different things. This is very much what in the old school days someone would say is left brain technology. Yeah, that's very analytical, very detail-oriented learning. But when you think about how you are driving sometimes, you are driving much more intuitively. Yeah? You don't calculate, I'm driving 50 kilometers per hour, there will be an impact in 50 meters, etc. But let's say you are driving and suddenly from the right there comes an animal, you immediately do something. So this approach of this right brain, where you are much more reactive and you're just more emotional or intuitive, is something that we try to mimic with perception fields. Perception fields is a technology that we train with a combination of imitation learning and reinforcement learning. And it tries to find out force fields in the video data. So you can see here, for example, that the car in front of you is braking, but you as a human didn't calculate this is 80 meters, now I should slowly push the brakes. But you sense some force field in which you say, oh, maybe I should put on the brakes. You will see similarly in this situation, they put a brake on because someone was entering the door of a car. Somebody is now coming out of the car, smiling at us, and the force field from this area comes, and then you push the brakes immediately and intuitively. Yeah? And the benefit of this approach is really that you have a visual explanation of the decision-making of the AI. Yeah? So you can also backtrace why the AI behaved in a certain way or manner. And you can also imagine that this technology kind of works additive. So these different force fields that we analyze, they function in a way that when you encounter new situations, you can actually push them in an additive formula and they will still work. So you have a much more generalizability of edge cases. And lastly, when you think about how you use your brain while you are driving, I'll make the assumption you don't use 100% of your brain all the time. And I'm not talking about being distracted in the car, but when you are doing driving functions in the car or implementing a brake or putting on the accelerator, you are not using your brain, all of your brain capacity. But rather, you access certain parts of your brain that help you to cope with such a situation. And as an example, or one of the visions that we are working towards is to mimic this behavior of the brain. So this means, for example, you have a situation as a sensor input where you see the child and the ball, and you intuitively know this is not a good situation. This is dangerous. But it's not the whole brain that does that. And now you know this is not good. I should put on my foot on the brakes. And we use a perception router that then identifies the best part or agent of your brain to perform this braking task, because this narrow AI agent has seen the situation many times before. And this is the idea of Eon, or this ensemble of narrow AI agents, to say, let's not use one gigantic network, but we can have many thousands, 10,000, 100,000, or even millions of these narrow AI agents that are very good at one specific task that they have been trained for and that the situation is that they have already seen. And this is why we believe such an approach of mimicking only a partial access of your brain is also another accelerator for autonomous driving and how you bring these streets to the car, or how you think about human level perception. So I hope I was able to challenge your thoughts about how AI is utilized today in autonomous driving and how we can radically reimagine it to work better in the future, that we all don't need to come into this situation with these horse carriages, but that the AI in the future recognizes that. Thank you very much.
Manuel, thank you very much for sharing these insights with us. And I will be honest, I ask that question quite often on stage, and I never get a real good answer. With all of these in my mind, when will I finally have my autonomous driving car on the road?
Yeah, I love that question.
I never get good answers, but I still keep going to ask.
Yeah, if you ask Elon Musk, I think he's been saying it for the past 10 years, that at the end of the year it will be there. But jokes aside, I think it will not happen in the way that we think it will happen, because you already see autonomous technology in the streets today. So you already have robotaxis in the cities of China or in the US in very limited domains, and the experience that you have is a much more limited one. So I think there we will see a much more evolutionary path, rather than this thing happening overnight and where you say, okay, now it's there. And on the other side, the cars that you drive already have a lot of autonomous technology that contribute to safety already today, that you can buy in your cars today. And so I think our mission as Autobrains is also to cater to both needs. I think we can already make cars safer today with our ADAS technology, and we need to invest in these level 4 technologies, but we think not in the traditional way, but we can mimic what the human brain is doing.
Maybe our next guest can help as well. But first of all, I'm going to ask you if you have any questions. We do have a question over there.
Yeah, I just want to ask, like, the quantum mechanica computer, like, there's also for the next years they want to develop it, and what you do, in common with that, if that's something you can use later on. I don't know how to explain it better.
No, thank you. I think quantum technology is the expectation that you have a quantum leap in the processing power and what you can do. And I think for the training purposes of an AI, this is amazing. But with where the technology is today, or what I see where quantum computing is today, with these huge machines that require a lot of power, etc., I have a hard time to imagine that you see a technological progress in quantum computers that you can put them into a car. Because the automotive industry is about costs, costs, and costs. And to get something into the car with its autonomous technology, but that is also affordable, that is the real consumer challenge. So I think in the car we will not see quantum computing, but it can definitely support us in training the models that we then run in the car.
Perfect. So, Manuel, as we do see each other in a couple of minutes for the panels again, I would say let's stop here. By the way, Shalav will also be back for that panel, so make sure to not miss that out. I would say for now, thank you very much and see you in a couple of minutes.
Thank you.
See you then.